Alright, so let's move into the problem number 11 now. Okay, let's read out the problem. So what is the problem says that this one is a 20 by 20 grid. So we have numbers with a 20 by 20 matrix. Okay, and if we just take four numbers in diagonal, for example 26, 63, 78 and 14, product of this four number is this. Okay, what is our problem? Our problem is what is the greatest product of four adjacent number in the same direction. That means we can take from any of the point. From this point we'll try left, we'll try up, down. Okay, let's say this is up for like 35, 75, like this, up, down, right, left, diagonal. Okay, so we can move to any direction, left, right, up, down and diagonally, and figure out largest product of that four adjacent number. So let's see how we can solve this problem. First of all, we'll have to create a matrix which will take all this number, and then we'll have to check each number. Okay, let's see how we can do this. First of all, let me copy this grid from here. Okay, so let me go here. Let's say that I create a variable like this, string matrix, and then I create triple quoted string. Okay, so I got this string matrix variable. Okay, then what I know that rows. Okay, rows will be that string matrix, string mat dot split. Okay, and we'll have to split it by new line. Okay, if you look at this string, why I'm doing that, you see there's a new line. There's a new line for every line. Okay, after every line there's a new line. For example, after 08 there's a new line. So if we just split it by new line, then we'll get rows. Okay, so let's look at rows now. So see, so for example, rows 1 is the second row, rows 0 is the first row, just like that. So we got the rows. Then what we'll do is we'll use a new library, NumPy library, because that will make our matrix multiplication faster. I'll just do this, import NumPy as np. Then what I'll do is, okay, if you don't have NumPy installed, you can just install NumPy like this. Okay, you can do it like this, pip install NumPy. Okay, so now what we'll do, I'll just create a matrix like this. I'll just fill up with zeros, initialize with zeros. So I can do it like this, np dot zeros, then the size 20 by 20. Okay, so I've defined the matrix. If you just look at the matrix, you see everything is 0. I have 20 by 20, and I can find out what is the size shape of it. This is 20 by 20. Now what I'll do, I'll just fill up this matrix. Okay, fill up the matrix with this value. How you can do it? You can do it like this. I can do it like for index row in enumerate rows. I'm doing this because I know the index will give me 0 for the first row, something like that, and then the content of the row. And then what I can do, I can just fill up the matrix index. That means the row position. I'm just filling up one row, and all the column values will be just do like this, row dot split. If we split by space, then it should give us the numbers. And if I just do it, it will automatically convert everything as number. Okay, split, split. Okay, now let's check the matrix. So we got all the matrix with correct value. Okay, you see that? Yeah, obviously it has converted everything into float, but that's okay. That shouldn't matter for our multiplication. Now we want to create a size. Okay, we want to create our problem. Let me add some space here. So let's say I want to create a size variable. Right now the size is 4 because we want to go diagonally up, down with 4 adjacent number, but we could go in any number. Okay, so that's why I want to make it parameterize. Now what is the total length? Total length is 20. Okay, then let's create a variable called product. is equal to 0. Okay, I think that should be enough. That should be our variable list. Now how do we get into this? Basically, how do we check into each number? Basically, we have to take every number, go from this direction, top and bottom. This is how we'll go. And in order to find out the product, so let's find what is the direction we can go. If you look at that, so let's say this is our matrix. Okay, because size is 4, this will be 4 by 4 matrix. And if we start from this number, then this is the right product. We'll take the 4 adjacent number and product it. This is the bottom number. Okay, and this is one of the diagonal number, and this is the second diagonal number. So let's say we got a 4 by 4 matrix out of this 20 by 20 matrix, and then we find this product. Now if I start here, product of this is same as if I start here, product of left. That means from this point, product right is equal to this point, product left. So if we just go along this matrix, and if we start from here, go like this, and obviously we have to stop here because we cannot go beyond 50, that it will cross. Similarly, we can start here and we'll have to stop here in 0, 4, otherwise it will cross over. And that means if we just start from here, end here, and keep doing this for every row. For every row, these are the column value. If we just take all these numbers, that should complete our search. Okay, so yeah, so let's create that loop. Okay, I'll create a loop for I in range total length. Okay, for j in range total length. Okay, I think I don't have to go until total length. I can go total length minus size. Okay, so that will complete our search. Then what we'll do, we'll create some variable, right? Let's say right product. Right product is equal to np dot product. So we have NumPy has a built-in product function. We'll take np dot product. Then we'll have to say for which element. Okay, so element, I will start with I, and I will start with ij rather, and j will continue because we are going in the right direction. I remains same, and j will start from 0 to 0 plus size. Okay, or maybe j to j plus size. Now similarly, we'll take the bottom. I'll just copy this. So we can go right, bottom, and 2 diagonal. That should be enough. Bottom product is equal to, as you can guess here I will change, but j will remain same. So that will be I plus size, and j remains same because we are just going towards the bottom. Then we'll have 2 diagonal. Okay, so let's say diagonal 1 product. Why 2 diagonal? As you can see, there are 2 diagonal, and this 2 diagonal value is not same. That will be different. So you'll have to consider both. So diagonal 1 product will be, let's do np dot product. But here actually we'll have to access the diagonal element from the matrix. Okay, so what is our 4 by 4 matrix? That is going to be I to I plus size. Okay, then j to j plus j to j plus size. So we got the matrix. Then find the diagonal of it. There is one diagonal. Okay, so let's create our matrix. Matrix will be this, and then there is a built-in function called diagonal. Okay, and that should give us the diagonal 1 matrix. But for diagonal 2, we'll have to basically flip the matrix. So it will be almost same. Diagonal 2. Here, instead of using the same matrix, we can use another np function, np dot flip r, and then pass this matrix so that it will just flip the matrix and then give us the diagonal. Okay, and we have to find out the maximum of it. So out of this 4 element, we'll just take the maximum. Okay, so let's create a max variable. Max variable is, I'll use built-in max function. I'll use this basically iteration. Let's say right product, let's say bottom product, then I have diagonal 1 product and diagonal 2 product. I'll take 4 of them, then, and I need to keep track our maximum product. If max greater than product is equal to max. So just keep tracking of the maximum, and let me remove the spaces. I think that should do our job. If we have done everything correct, it should work. Let's check it. Module numpy has no attribute called flip r. Okay, it should be flip lr. Okay, yeah, looks like it did work. Let's check the value of this product. Okay, it doesn't look like it's right. Okay, so let's check diagonal 1 and diagonal 2. Diagonal 1, okay, that doesn't look right. What about diagonal 2? That doesn't look right either. So what's the problem? np.product. Okay, what about I? What about j? It's 15th. Yeah, 15th should be fine. But the question is, let's check this. Okay, let's see. That cannot be the case. Okay, there is a mistake here. J to j plus size. Here again, j to j plus size. Yeah, that looks correct now. Now let's look into this diagonal 1 now. Yeah, the contents value. Yeah, I think that's the answer. Let's check it. Let's try to check it. Let's see if it is working. Okay, I'll just create this integer version of it, because yeah, that should be our answer. Let's check it. Okay, again I am signed out. 41869. Yeah, our answer is correct. So that's it for the current edition. Thanks for watching. Coming up next is problem number 12. Thanks.